Good morning, St. Peter Algebra class. I would like you to, we're going to be starting a new chapter here. Can you get used to pausing the video and starting it up? So for example, I'd like you to pause right now and try those first 6 problems. And after you give them a shot, then start the video up again. Okay? All right, welcome back. So the equivalent percentage for this, if you notice, you can reduce this dividing by 4. That reduces to 1/4. And to get the percentage, you can, of course, do 1 divided by 4, or you hopefully just, this is one of those percentages, I'm hoping you just know that 1/4 of a pizza or something is equivalent to 25%. Okay, 12 over 60. Got a greatest common factor of 12. We can divide that out, and we get 1/5. Now, I'm not sure, maybe some of you know what percentage that is. If not, you can certainly divide it. So it's 1 divided by the 5. The decimal here. 5 goes into 1 nothing, 10 twice. And that's it. So 0.2, you move the decimal 2 spots to the right, which is the same as multiplying it by 100, and you get 20%. And 35 over 280. Let's see, what is the, obviously you can divide them both by 5. Let's see here. Oh, you can divide them both by 7. Actually, can you divide them both by 35? Yeah, nice. That's 1/8. Now, and again, you can use your calculators. I just want to make sure you don't forget and just use them all the time. So 1 divided by 8 is 0.125. Move the decimal 2 spots, and you have 12.5%. Okay? Now, find each value down here. Remember, alpha is like multiplication. And just go ahead and take that percent and change it to a decimal. That's moving the decimal 2 spots back to the left. And then 2.2 times 360. 72. 1/15 of 360. So again, that's multiplying. But since you're multiplying by 1/15, that's the same as dividing by 15. Because if you multiplied, you could put this over 1, and you're going to get that. 360 divided by 15 is 24. And, oopsie, it's not last. I went out of order. 75% is 0.75 times 360, and you should have gotten 270. So hopefully you guys got all those right. If not, you can review that again if you need to. You can always re-listen to the work. So we're going to talk a lot about graphs in here, organizing and displaying data. Super fun chapter, and it's also just really booming out in the field of careers. Actually, Katie, my oldest, is planning on going into data science, and she talked to somebody from General Mills Company, and they apparently have really expanded the field of data science at their company, and I think that's pretty much happening all over the place. So if you find that you really enjoy data and math, you might find that a career to think of someday. So again, I want you to pause the video. I want you to look up these page numbers and find out this information, and then come back to the video after you've filled it out. Go ahead now. All right, trusting everybody did it. Everybody. I won't mention any names. Just kidding. So what is a bar graph? A bar graph displays, you can check your work here, data with vertical or horizontal bars. What must a double bar graph have? And that's a key. A key is something that's listed on the graph, and I'm going to show you a bunch of graphs in a minute that clarifies the difference between the 2 bars that are side by side. What is a line graph? It displays data using, of course, a line. And when is a good time to use a line graph? Line graphs are often used when there's change over what class? Time. Yes, anytime you want to see how something changes over time, you'll see a lot of graphs with this coronavirus. It's a great time to start analyzing graphs, and you can see a lot of it is over time. So you'll see some line graphs. You'll see some logarithm graphs as well, which we won't get to right now. What must a double line graph have? Again, the same thing as it did up here. It needs to have a key that tells you which line represents what, because there's going to be two lines on there. And what is a circle graph? It's a circle graph, and it always shows you parts of a whole. So there'll be like 100%, should be on there. So if we're trying to find what the circle graph of 6th, 7th, and 8th graders in the algebra class, by the time we're done, we have 100% of the kids represented in there. So there'll be a certain percentage that is for 6th graders, a certain part of the pie that is for, let's see, our smallest one in there is our 7th graders. Well, that's very small, so that's totally not right. And then it's even bigger for the 6th graders, and then the 8th graders are the biggest group in there. And that is just one bad circle graph. Sorry about that. All right, thankfully we have some graphs to look at. So I asked you to print off all these pages. So hopefully you have these printed off. I want you to look at this. This is the bar graph. Again, I'd like you to pause the video, and I want you to just try these. I think some of these are pretty straightforward. So go ahead and do these, and then come back to find out if you got the answers correct. All right, so this is a bar graph that's horizontal bars. They're going horizontally. You can see them both ways. Which casserole was most ordered? You should have had lasagna. So you can check your work. I'm not going to take a ton of time on this because I think you probably did this in previous years. About how many total orders were placed. Okay, so you would need to add each of these up. So this is 20, 40, this must be 60 here. So that's 60. This one looks like it's, let's see, between 20 and 30. It's almost at 30, so that's probably about a 28. And you continue to do that all the way up. You kind of estimate how many each one is, you add them up, and it should have been about 179, give or take 2 or 3. If you're off more than 5, then you missed a whole chunk in here somehow. You were incorrectly reading the graph. About how many more tuna casseroles were ordered than King Ranch? Should have had about 11. You just find the tuna, which is, looks like it's about 42. And you're going to subtract or find out the king. I don't know which one's bigger. It looks like that's about 32. Actually, it looks more like 31. Subtract them and you get about 11. And lastly, about what percent of the total orders were for the baked ziti? Okay, the baked ziti looks like it's coming in at, I'll go with 19. And then you would, to get the percent of total orders, it's that part over the total amount, which we had up here. So 179, and it should be about 10%. I don't know if that one is actually, let me just double check mine here. Actually, this one's about 11 on mine, came out to about 11. So it's somewhere in that ballpark. Next. Take a look at the next one, which is a double bar graph, although this one is going vertically. So we said before that the important thing you needed on these graphs was a key, because otherwise you don't know what in the heck is what, right? So this key is difficult and this printout is difficult because you can't see the colors. So I'm going to help you with that and tell you that the red one is always this first one here. Okay, that's the red. So maybe you can just outline that on your graph. There we go. And we'll just assume that the black is the second one. Okay? So now to answer the questions, Which feature received the same satisfaction rating for each SUV? So when we look at these are all the different features down here. So the feature that had the same was right here, and that would be the cargo, which is basically talking about how much room it had and space inside for cargo, for stuff. Which SUV received a better rating for mileage? So you go out to mileage, and you're going to look and see which one got a better rating. Looks like the second one, which we said was the SUVY. Okay, going to the next one. We are now talking about a line graph, which we always said is great to be used when you're talking about time. So this happens to be actually all happening within a day, but it could be something happening within weeks or years. So, but it is definitely over time. And it says at what time was the humidity the lowest? So this is the humidity, and we want to see where it's the lowest, and it looks like it's at about 4 a.m. During which 4-hour time period did the humidity increase the most? It increases here and increases here. I think I'm going to go with this one. It's kind of hard to tell, actually. No, I do think 12 to 4 is actually the one that has the biggest increase. Sorry, I haven't been giving you time to do these on your own first. Hopefully you're stopping and doing it. All right, next, circle graphs. Go ahead and try to answer this question, which is quite easy. I think you'll all get it, and then push start when you're ready. All right, so this is a hard one again to read because of the printout. But when we look to see which ingredients, we can tell by the listing of the percentages. So that does help. Which ingredients are present in equal amounts? It appears to be these two. They're both 12.5. So you would say lemon sherbet and pineapple juice. Sorry, my table's shaking. Okay, and notice these add up to 100. It's a 360 degrees for a circle graph, but the percentages should equal 100. All right, now we're going to talk about organizing and displaying data. So here we have, what kind of graph, guys? This is a double line graph. And if you notice, I didn't really point this out, but the titles are always up here, and actually I would suggest you go back and highlight those so you remember the names. And again, since it's a double one, you need to have a key, and here it is. The diamonds are station A and the circles are station B. So I'm just going to go through, because it's kind of hard to see where it is. I'm going to follow the station A with my red pen. There, that kind of separates them a little bit more. Okay, go ahead and try A and B, and then come back to see if you got it right. Go ahead and push pause. All right, in which month did station A charge more than station B? So we're looking to see where the diamond, where my red line is higher than my circles. So this is lower, this is lower, this is lower, this is the same. Okay. So we jumped up right here. And what month would that be? That's this one. Hopefully you guys know your months. January, February, March, April, May. During which month did the stations charge the same? So we're looking for where they overlapped. So they didn't overlap here or here or here, but here they did. No, no. Here they did. No, 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 and no. So we got two of them. A, which is for April, and J, the second J, let's see. January, February, March, April, May, June, July. All right. Now we are going to talk about, let's see here. How do we know which is the right graph to use? So this is where it gets a little tricky, because you need to figure out, oh, should I use a bar graph? Should I use a circle graph? Should I use a line graph? And in this case, I don't see anything about time. So I know it's not going to be a line graph. Okay, and I also don't know that this was all the flowers in the arrangement necessarily, so I don't know that I have the whole amount, so I'm not going to use a circle graph. I think a bar graph in this case is the best, and you can choose either one. You can do a horizontal one or a vertical one. So pause the video. I want you to try this on your own and then come back, and I'm going to write both of them on here, okay? If you don't understand how, you'll see when you come back. All right, so let's do the horizontal one first. We're going to put the flowers on the side, so we'll have roses, lilies, agapanthus, I'm not sure, and peonies. Okay, those will go across, and then the amount on the bottom, and I see that it has to go up to 6, so I'm just going to go by 2, 4, 6. I don't know why I put this here. That doesn't really need to be there, nor does this, so I'm not sure what I was doing there. But anyway, all right, so the roses go out 6, so I'm going to draw a bar over 6, and I'm going to fill it in. And the lilies go over 4. Now notice they don't touch each other. Okay, in the future we're going to have a graph that is going to be where these actually will touch each other, but not in the bar graph. And this agapanthus, somebody can correct me because I know I'm saying it wrong, and one of you probably knows the right way to say it. And peonies is 3. So go right between the 2, and there we go. Okay, and this is the number of flowers. Got to label my graph. And this is the type of flower. And we'll title it Flowers in an Arrangement. All right, now we can do the vertical one. And we'll put the numbers on this side now. Number of flowers, I'm just going to abbreviate, and type of flower. So we'll put roses, lilies, and peonies. 2, 4, and 6. So if you did roses, you did all the way up to 6. And if you did lilies, it goes to 4. And that goes up to 6. And peonies go to 3. And again, the same title. So there you go. I want to keep moving here. It's getting long with all these graphs. I don't want to keep these videos too long. All right, next we have this one. How do we know which one to do? Okay, degrees held by faculty. Now they're kind of assuming, I think, that this is the total number of faculty members here. So this is 100% of the faculty members. So when we add these up, we know that we are going to have, let's see here, that's 30, that's 61 faculty members. Okay, so a circle graph is going to be a wise choice on this. And I should have my compass here, which I don't. Sorry about that. But you're going to want to use a circle when they make up a whole. Okay, the whole 100%. And now this can get a little tricky because this adds up to 61. So I need to split this up to figure out what percentage of this is each. So I first have to find out what percentage of the 61 do I have. So I'm going to take the 6, I'm going to divide it by the total. Okay. And once I get that, and then I'm going to multiply that by 360. So that'll tell me what the degrees is. So let's try that. So 6 divided by 61 equals, it's a decimal, times 360. And you get 35 is what mine is. 35 degrees when I round it to nearest whole degree. Let's do the masters. Again, you take the part, 24 over the total, and times it by the 360 to see how many degrees. 24 divided by 61 times 360 is that 142. And oh dear, that is going off for something. Oh, it is Divine Mercy time, 3 o'clock. I will do that as soon as I finish this video. 31 out of 61 equals, and then multiply it by 360, and I got 183. Now hopefully they come out even because there is some rounding in here. Let's see here, 35 plus 142 plus 183 adds up to 360 degrees. Perfect. So then you're going to want to get your protractor out. I'm going to pause the video because I have to go get my tools. I am unprepared. Hang on. All right, I'm back. So I put a better circle on there. I had my compass. And then you're going to want to put your radius on here. Use your straight edge. And then we need to get that degree measure on there. So you can start with whichever one you want. I'll just do the 35 degree first. So you're going to want to make sure you line up your protractor here properly, making sure that it's lined up straight across. Okay, and then we need to go out 35 degrees. So I'm going out 35 from this point up to 35 right here. And we'll extend that out. There we go. So that is the PhDs. And there were 6 of them. Then I need to do 142. So you can just turn your paper a little bit if you want and go to the top of that line. Now I don't go to the same line. I go to the next edge here, right here. I need to go out 42? So I'm starting here and I'm going all the way around to 140, between 140 and 150. And it's right in the middle of all my writing. I gotta double check that it doesn't. Oh yeah, it is right. Sorry. Oh, there's my dot. Oh, look at that. I like to be nice and neat. Okay. So that is the masters. There are 24 of them. And of course, what's left then is your bachelor's degree. And that would be, well, we're putting the number in 31. Okay. So that is probably the trickiest part of this section, which you'll be fine. We have one more left. Let's take a look. And that is farms. And we can see that they're doing time. So a great choice for this is going to be a line graph. It's over time. Okay, and you want to put the time on the bottom. And let's look at the years. It's going from 1880 all the way up to 2000. So you want to have equally spaced increments. So I'll just start with 1880 here. And let's see here. I think I'll go up by 40s. You can go up by whatever you want, but do an equal space. Could have went up by 20s or whatever. And then the number of farms goes all the way up to 265. So I'm going to start at 0, and I'm going to go up to 265. I think I'll go by 50s. Same increments between. Oopsie, gotta go a little higher. Okay, I'm going to label it. This is the year. This is the number of farms. This is the county farms. Okay, and so we're going to put a dot in there at each of these. 1880 is 265. So you kind of guesstimate up here. I mean, you don't know exactly. 1920, 248. It's close to that. And 1960 is 124. And 2000 is 53. Now when you go, you want to take your straight edge, and you're connecting one to the, in sequence. So that went from this to this. That went to this to this. And that goes from this to this. And we are done. That was probably the longest video of the week. But I hope it's very clear, and if not, you can rewatch the things you need. Have a great day. Bye.